Here we have an example of a problem that is asking us to find all the horizontal asymptotes of the given equation. When we're talking about horizontal asymptotes happen in two places. We oftentimes remember the first one. The first one is usually the one you see the most often. That's the limit as x approaches infinity. So as x is headed off in that direction, what is the long-term behavior? What is the horizontal asymptote? The one that people often forget is when we're headed off to negative infinity. So the limit as x approaches negative infinity. Negative huge numbers also will affect the long-term behavior of the graph in that direction. So when they're not giving you a specific limit to follow and they're only asking you to find all the horizontal asymptotes, then you need to know that that means this problem is going to get broken up into two directions every single time. So what you're going to want to do is you're going to want to take this on in two separate problems. The first will be the limit as x is headed to negative infinity. So you would come through and you would say, all right, I'm going to rewrite this equation. Limit as x heads to negative infinity of the given equation, 3x minus 2 over the square root of 4x squared plus 5. And then we're also going to be heading off to positive infinity, the one that we always seem to remember. And it's important because you can have two different answers going in two different directions, because one is headed to a positive huge number and the other one is headed to a negative huge number. So there's our two limits. And now as we look to address them, what we can see is we have this situation where we've got a square root. We're looking to find what we refer to as the dominant power. We want to do this method of dividing by the highest power of x. But when you look at a square root and something outside of a square root, you have to think about what those two pieces mean. Because as I look right now, I'm looking at a 3x and I'm looking at a 4x squared. Well, remember that inside a square root, when I square root an x squared, that what I get out of there is a positive or a negative x, right? And so when you are looking inside a square root function, you always are essentially dividing that highest power by half, because that's what the root is doing. So if you had the square root of x to the fourth, really that's like having x squared on the outside of this. And so when you go to divide by the highest power, on the outside, you're going to divide by what's outside the square root. And when you're inside, you would divide by what that would look like inside a square root. So coming back to our problem right now and using this dividing by the highest power of x method, we would have the limit as x heads to negative infinity of 3x over. And the trick on this, when we're headed to negative infinity right now, is these values that would come out, these would be negative x's. So what we want to divide by is that negative x, because we're headed to negative infinity. So minus 2, divide by negative x. And then as we go inside here, now we're just going to divide by the x squared, because when you square a negative, you're going to end up with a positive. So we don't have to worry about the positive negative game. We get x squared and then divide 5 over x squared. Now what you're going to do is you're going to simplify this down. You're going to simplify it using a rule that they often give you when you're working on this section. They tell us that the limit as x heads to positive or negative infinity of 1 over x heads to 0. So anytime we've got a number over x, and that doesn't matter how big or small that number is. This could be 3 over x cubed. You're still getting out 0. So when I come to clean up my problem here, I'd say, okay, I've got the limit as x heads to infinity, negative infinity. I've got this x on top is going to cancel out the x on bottom, and what I'm looking at in that first term is a negative 3. And then here I've got a negative negative, that's going to be a positive, but it's a number over x, so that thing's going to head to 0. That's using our definition here. And then on the bottom, I cancel out those squareds, so I end up with the square root of 4, and then this is that same definition, that's going to head to 0. So cleaning this thing up, on top I've got negative 3, on the bottom I've got the square root of 4, which is really negative 3 over 2. That's a y value. y equals negative 3 over 2 is our horizontal asymptote as we head to negative infinity. Now going back and doing the same work with our positive infinity, again, we're going to go through and divide everything by that highest power of x. So we get the limit as x heads to infinity of 3x over, and because we're now headed off to the positive side, we're going to divide by that positive x value. So we divide by x, oops, that's not a plus, that's a minus, minus 2 over x, and then on the bottom here, again, inside the square root, we're going to divide by x squared. And because it's squared, it doesn't matter positives or negatives. So divide everything by x squared. And now we come back through this, and we're going to go ahead and we're going to use our definition over here to simplify this thing down. We're going to get limit as x heads to infinity. The x's are canceling. We get a 3 over 1, which is just 3. This is our definition down here, so that's headed to 0 again. So 3 minus 0 over the x squareds cancel, so we get the square root of 4 plus, and there's our definition again. That thing is headed to 0. And now when we finish this thing out, we end up with on top a positive 3 over on the bottom square root of 4, which is going to give us positive 3 over 2. So our horizontal asymptote as x heads to positive infinity is y equals 3 over 2. So you can see that it is important to know which direction you're going. It's also important to remember that when someone is asking you to find the horizontal asymptote, that means you need to find two different limits. The limit as x heads to positive infinity and the limit as x heads to negative infinity. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.